2.4 meters, that height here for part B is going to come into play. 2.4 meters, thank you very much. Oh, but of course we're not doing the same problem, so let's say he's holding it 1.5 meters above his head. Now, we have to figure out how far away from Marcus the ball will land if Jill, if she misses it. So, what I'm going to do is I'm going to figure out how long this ball is going to be in flight if the total y displacement has to be negative 1.5 meters. If we're just saying, okay, well, this ball's going up with this initial velocity, but then it's going to come down and it's going to fall another 1.5 meters down. Luckily, all of this stays the same. The acceleration due to gravity stays the same. So what we could do is we can plug into this same equation, really good, handy equation. And of course, when we plug in, negative 1.5 equals 7.07 t plus half of the acceleration due to gravity, so that's actually going to be minus 4.9 t squared. The trouble with this is a quadratic. So if we do a little rearranging, maybe I'll just add 4.9 to this side and subtract 7.0. We'll get 0 equals 4.9 t squared minus 7.07 t minus 1.5. And you can plug this into your Pythagorean equation and you're going to get, I keep saying Pythagorean equation, Pythagorean theorem. This is the quadratic formula, pal. Gosh, it's a good thing it's just you watching this, huh, Ethan? Okay. So this is negative b, so 7.07, plus or minus the square root of b squared, so 7.07 squared, minus 4ac, which is negative 1.5. Awesome. All over 2a, which is 9.8. Awesome. So we plug this into our Pythagorean, oh my gosh, plug this into our quadratic equation, geez Louise. And you could do all this out, just make sure you follow the order of operations in there. Or if you're fancy like me and you've got this graphing calculator, you programmed it ages ago. And you can just plug in negative 7.07 and negative 1.5. And I will show you how to do this. You get that your possible time for the total arc there is 1.63 or negative 0.18. And of course, negative 0.18 or 1.63. And we don't have negative time. We don't live in that dimension. So there's our time. Then we know our time for our total arc, so then it's just a classic dx equals vox t plus 0. You know, forget it. We don't even need the ax. We know it's 0 every time. So then this is dx is our initial horizontal velocity, 7.07 times 1.63. 1.63 times 7.07. And we see that it actually falls a little bit further past Jill, about, what was it, about 1.5 meters past Jill? I can't remember what Jill's was, but that's how you solve the second one. Basically what you do is you set your y displacement to negative of the height, use the quadratic formula to solve for t, and then use that time to figure out the horizontal range.